Hello. I believe it's been about a week since my last video. Clearly my upload schedule is shit. Anyway, let's begin today's video, which will be on insertion sort on a linked list. It's a medium difficulty problem on leetCode. As we notice on the right, here is my solution. It obviously works given that submissions all passed. I don't know why I submitted it 3 times, but anyway. Let's go ahead and begin writing the code. First thing we'll do is let's get rid of the code so we can build it from scratch. And before we start, let's just go up here to this function I created called traverse linked list. This is not part of the solution. All it does is traverses a linked list and returns all values. I just did it to help me down here when I'm traversing my linked list to ensure that it is in fact sorted. Anyway, let's begin. If you want to know the theory behind the video, that will be my last video explaining how to actually sort a linked list. When I say sort, I mean how do we put node A in the correct position in the sorted linked list. Let's begin. The first thing we'll do is we will create a new linked list. We can call it anything, but I will give it the apt name sorted list. I'll then use dynamic memory allocation to allocate it to, actually let me go ahead and just show you guys. Here is the list node above that's given to us in leetCode, and this comment section right here, this is also given to us in leetCode. We notice here the steps. I just copied it and I pasted it here just so that it's a little easier. So the first thing we'll do is we create a new linked list. It'll be the sorted linked list, and we will assign the value pointed to by the first value in the unsorted linked list. Now, next thing we'll do is determine if we left insert, so left insertion or right insertion. Insertion. I should not be making these videos in the morning. I am incredibly hungry. Insertion. I'm drinking coffee, which is not a good thing. So, the best case is if it is a left insertion. That is the easiest case, because all we have to do is take the new node, point it to the current lowest node, and then have the linked list point to that new current lowest node. So we'd say if, let me go ahead and create, I think I'm missing a step. Let me go back here. So now that we have the first node of the linked list, we can just go ahead and increment it to have it point to the next node, because no need for us to consider the same node twice. It is also the node used for traversal. Typically, we may set a temporary node to the head node, but that's irrelevant in this case because we don't care if we exhaust this linked list. In fact, we want to exhaust this current linked list. Node used for traversal of the unsorted linked list. We will then say while head is not equal to null pointer being indicating the end of the linked list. We will determine if it is a left insertion or a right insertion. We go ahead and we'll create a new list node. Let's call it new node. We'll set it equal to new list node, so dynamic memory allocation again, and it will be the current value pointed to by the head node, null pointer. Okay, then we determine if it's a left insertion or a right insertion. So if new node value is less than or equal to sorted list value, so this just compares the current new node's value to the lowest sorted list value. This one's easy. This is a left insertion. Left insertion. Then we say new node. Next, so the pointer points to sorted list. And then sorted list itself points to new node. Alrighty, that's great, that's easy. Else, now this is where a little more work comes in. This is where we have right insertion. So the value we read, it's larger than this current smallest value of our sorted linked list. And there's one of two possibilities from there. it's either added to the end of the sorted linked list, i.e. it's the largest value, or it must appear between two values. So write insertion, two possible cases. You'll then create a new list node, call it whatever you want. I call it current. It'll be initialized to the sorted list. We then create the next one called list node, of type list node, and it will be called precurrent. Precurrent will point to null pointer. Now that I think about it, I could have just created it and it would point to null pointer. Anyway, we'll found. We'll set this to false. Do I need it? I'll keep it for now. And then while current is not equal to null pointer and not found, we'll start searching. Example of this is, let's say our current linked list is something like 1, which points to 2, which points to 3, which points to 4, which points to, say, null pointer, and we go ahead and we read in some value 6. 6 should end up being inserted at this position here. We then say if current val is greater than or equal to new node val, then found is equal to true. For u and d, found is equal to true. Else precurrent will point to current. As we notice, current points to a node, precurrent points to a node before precurrent. So once we set this, we have to obviously advance current to ensure what I just said remains true. Current next. We'll then break out of this. We found our node and we say precurrent points to, so next, so it points to new node. New node itself next points to current. We can then advance head. Where should I advance it? Oh, I think I should advance it here. So head is equal to head next. No. Next. And then what's happening here? Nope. And then we'll go ahead and we will finally, once out of this loop, so the loop's here. Return sorted list. Let me just go through everything. So we initialize our list. Okay. In fact, I'm just going to try building it. I don't want to go over the code. We'll build it. And it's working. Alright, there we go. 0, 1, 2, 3, 4, 5, 6. That's weird anyway. So I created a linked list around here. The first value being 4, then 4 points to 3, 3 points to 2, 2 points to 1, 1 points to 6, 6 points to 0, 0 points to 5, creating this last linked list here, which obviously we can see it's unsorted. And I have a helper function called traverse linked list. My dog is barking. 1 second. Alright, I'm back. My dog was barking for no reason again. She's seen ghosts, of course. So as I was saying, this traverse linked list function, it's not part of the solution. It's just used as a helper function, just so that we can print out all the values of our linked list. If you want to know how to do it, here's the function right here. It's very simple. If we go ahead and take that code and paste it into leetCode, we run it. We get our solution. We can do a submit. Now, something you should notice right here is found true. This is irrelevant. Obviously, when I was coding it, I was building it by portions of portions. trial and error, if you will. So when I created it, I initially was using the found value. Towards the end, I was not using it, but since I had it there, I was like, no point of me taking out now. So, and then once you do find a value right there, that's where we actually use it. So this essentially evaluates to, how can I say it? Searches until we reach the end. Will search, no, well, current searches until current not equal to null pointer and not found being not true. So not found being false. And that would be it. Obviously, it's a decent solution for 3 milliseconds of runtime, 10.12 megabytes. There is a different way that it can be done. But the issue with it is if you do it that way, which I'm about to describe, which is create a dynamic container, so a container that can grow, such as a vector, store all your values within the vector, sort the vector, then create a new linked list, that's fine. But the problem says insertion sort algorithm on linked list. As you can see down here, just this picture right here, the using insertion sort on the linked list. So I wouldn't consider that. If we go down to discussion, for God's sakes, don't try sorting a linked list during the interview. It kind of true, it's a little annoying. Let's go ahead and look at submissions. Let's go to runtime. Let's look at some good solutions. Nope, I don't want to look at my code. Okay, here's an example. Actually, one of the best solutions in terms of runtime is one that creates an additional container called nums, which is a vector. Then we push back all the values, so append all the values to the vector. We then sort the vector and then create a new linked list. So yeah, that's the code. Cheers.